T175, section 5.1, composite functions. I'm going to form a composite function. Well, what is a composite function? Basically, we have two functions, f and g. And we're going to write this as f of g of x. And notice this looks like a circle and not a dot. So the second term, that's going to be inside the f of x. So we're going to write this as f of g of x. And so the domain is going to be dependent not only of g of x, but also g of x and also f of g of x. Alright, now here we have f of x is a 2x plus 3 and g of x is 4x cubed plus 1. So we're going to write this as f of g of 1. So first thing we have to do is find the g of x. So we're going to take the inside term and put that g of 1 in there. And so that will be 1 cubed times 4 plus 1, and we get 5. So we're going to take that and plug it into the f of x. And so when we do that, that'll be 25 squared times 2 plus 3 is going to be 53. Okay, so the b, we're going to find g of f of 1. So this time the f of x is inside the g of x, so this time since f of x is inside, we have to find that first. And so f of 1 is going to be 5. And so now what are we going to do? You should have said we're going to take that 5 and we're going to put that in for g of x. And when we do that, we get 501. Okay, part C, f of negative 2. Now, basically, we put an f of within itself. And so this will be f of negative 2. So what do you think we need to do first? Okay, you should have said that we're going to take negative 2 and we're going to put it in f of x. Okay, and so we do that and we get 11. Now what are we going to do? Okay, you should have said that we're going to, because this is f of f, right? Now we're going to take that 11 and what are we going to do with that? You should have said we're going to put that back into the f of x equation because this is f of f. And so when we do that, we get 245. Alright, and then part D, this is g of negative 1. Okay, so we get g of negative 1 here. So what do you think we do first? You should have said we take negative 1 and we put it into the g of x. Okay, and so we do that and we get negative 3. Now what are we going to do? Okay, you should have said that we're going to put that back into the g of x equation again. We're going to take the answer, so we're taking the output of the inside function and we're going to put it into the outside. And that's going to, the output of the inside function is going to be the input of the outside. And so we get negative 107. Okay, find the domain of a composite function. Okay, we want to find the domain of f of g. So basically what we do here is we want to find f of g of x. We want to find that domain. First thing we do is we always find the inside part first. Okay, and we look, and the domain for g of x is basically all real numbers. Now what we're going to do is we're going to take that 4x plus 1 and we're going to put it into the f of x. So let's see what that looks like. So this is what we have so far. We've got we've got f of g of x, and so that'll be f of g of x. So we have to find, so basically what we're doing here is we're looking at, we take x does not equal to, what this first part here is going to be our inside, and then we're going to look at the outside. Okay, so we're looking at the domain for g of x, which is 4x plus 1. And we know that's all real numbers. There's no restrictions there, right? There's no x in the denominator, there's no x in the radical, so it's all real numbers. So basically, what we do at this point is we put the f of g of x. Now we're going to take a look at f of g of x. Well, here's f of x is equal to 2x squared minus x plus 4. So basically what we're going to do here is we're going to cut this x out. Cut the x out. Cut the x out. And so what we have here is just f of parentheses equals to 2 and then parentheses squared, where the x is we put parentheses, plus 4. Now we're going to put the g of x in there. So here's g of x, and so we're going to put the 4x plus 1 in there, and 4x plus 1 in there. And so it's in order of operations, this square comes before multiplying. This will basically be 4 times 4x plus 1 times 4x plus 1. And then here we can distribute this negative. And so it's negative 4x minus 1 plus 4. Now what I like to do at this point is I like to go ahead and distribute that 2 into that first factor. And so that'll be 8x plus 2 parentheses 4x plus 1. And so this, again, this will be minus 4x plus 3. And now we will FOIL. And so that'll be a 8 times 4, that's 32x squared. And then plus 8x. And then plus 8x again. And then plus 2 minus 4x plus 3. And so we end up with f of g of x is going to be 32x squared plus 16x plus 16x and a minus 4x, so that'll be plus 12x. 2 and 3, that'll be plus 5. And so we can see from here that that domain is also all real numbers. Okay, so this all real numbers, and this is all here all real numbers, so our domain is going to be all real numbers all the way around. Okay, and so that's our g of x. Substitute g of x in for f of x. Okay, and we got that. And so we can say the domain of g is all real numbers. Domain of composite function f of g is also the set of all real numbers. Okay, now g of f. So now we're going to find our domain for f of x first, because that's on the inside. Well, what's the domain for f of x? You should have said all real numbers. Okay, and so now we're going to take this. Now we're going to take g of x, right? We're going to cut the x out, and then we're going to take this equation and put it inside where the x was. And now we're going to distribute that 4, and we're going to see that the composite g of f is also all real numbers. So the domain all the way around is going to be all real numbers. Okay, so we're going to take if we're looking at f of g, we take the inside domain first, and that's kind of going to be separate. And then we have to take the composite of the two. And then we basically have like two parts of our domain. Okay, so here's our f of g of x. Okay, so at this point we need to find the domain for the inside first. G of x is equal to 2 over x plus 1. So how do we find the domain from here? We should have said set the denominator equal to 0, and we know that x cannot be a negative 1. So far our domain is a set of all values in set x, where x cannot be a negative 1. But we have to now find our domain for f of g. So here this was the g of x part. Now we need to find the f of g of x next. So we don't know what that is yet. Okay, we got to find that. Alright, so at this point now we take the f of x, here's f of x, right, which is 3 over x minus 5, and now we're going to cut that x out, and actually I'm going to use red for that. We're going to cut that x out. It's like we're cutting that x out, cutting the x out here, and so this will be 3 over, and then where the x was we put parentheses, minus 5, and now we're going to put the g of x in there. Well, g of x is 2 over x plus 1. Okay? Alright, now at this point we need to get rid of that x plus 1. So what we do here now is we take the denominator, we multiply x plus 1 over x plus 1. Well, at this point we have to distribute that into everything in the denominator. And so the way this looks, this will be 3 parentheses x plus 1 over 2 over x plus 1 times x plus 1 minus 5 times x plus 1. Okay, so we distribute that x plus 1 into both, and that's what this is here, but the x plus 1's cancel. So we end up with 3 parentheses x plus 1 over 2 minus 5 times x plus 1. Okay, and so we can distribute here at this point, right? So that'll be 3x plus 3 over 2 minus 5x minus 5, and so we get 3x plus 3 over a negative 5x minus 3. Okay, and so now what we do at this point is now we're going to set the denominator equal to 0. Set denominator. Now we have to find the domain for f of g. Equal to 0, and then solve. So we're taking this negative 5x minus 3, set it equal to 0, add 3, divide by negative 5. And we get x cannot equal to a negative 3 over 5. And so that's where we get this. So now this will be x cannot be equal to a negative 3 over 5. Okay, and so that's our domain for this composite function. Alright, and so that's what they're doing here. Okay, we know that we cannot have x cannot be negative 1 and x cannot be 5. So, but what we're going to do is we're going to take that negative 1, that's the first half of our domain. Okay, set the x plus 1 equal to 0, and we get that x cannot be negative 1, and then for the composite we substitute in the g of x in. And then here we multiplied that x plus 1 over the x plus 1, and we got that 3x plus 1. And then here the x plus 1's cancel for the 2, and we distribute it, and we get here they factor the negative out. But when you go to solve for x plus 3 here, subtract, set that equal to 0, minus 3 divided by 5, you still get negative 3 over 5. So here we have, this is the domain for g of x, and this is the domain for the composite, f of g. Alright. And we'll be doing another one of those in class. Okay, now we want to find f of x. So basically, we're going to find the domain for f of x, because that's the inside, and we know that that's x cannot be what? X cannot be 5. That's what we have here. Okay, so we know that x cannot be 5. Okay, so basically what we have is our domain is the inside, comma, and then our composite. Okay, and so we know that x cannot be 5, but now we still need to find the composite, the domain for the composite part. So we go ahead and we are going to, here's our f of x, that's the first part. So now we're going to take this and we're going to put that inside f of x. So we're going to cut this x out, and we're going to put this 3 over x minus 5 inside of there. Okay, now at this point we're going to, what do you think we got to do here? We've got to multiply what? X minus 5 over x minus 5. Okay, so we got to distribute that x minus 5 into both, right? That's going to cancel this with this x minus 5 here. And so that's going to give us that'll cancel this denominator here out, because the x minus 5, right, and here this would be x minus 5 here, these two x minus 5's canceled out, and so that's why there's only 3 left. And so now we can just distribute from there, and it simplifies out to 3x minus 15 over 5x minus 28. Alright, now what do you think we're going to do at this point? Alright, you should have said that we're going to take this denominator here, negative 5x plus 28, set it equal to 0, minus 28, divided by negative 5, and the negatives cancel out, and so our domain is going to be, we already know that we cannot have x cannot be 5. And so now we also know that x cannot be 28 over 5. Okay, and so there's your inside and your composite. And so that's what and there we go. There's our domain. Okay. We want to show that the two composite functions are equal. So basically what we do is we take the first composite and we put it into the second one, and then we take the second one and put it in the first. Now what we should end up with is, if these are both inverses of each other, then what we're going to end up with is x. That's all that's going to be left, and that's what this means. F of g of x equals a g of f of x. So if we put these in here, after everything cancels, all we have left is x. So we're going to start with f of g of x. And so it's like we're cutting that x out of the f of x, and we're going to put the g of x in there. Okay, so here we start with g of x, right? And so at this point, we're going to take, it's like here's f of x equals to a negative 2x plus 1, and we're going to cut that x out. We're going to cut that x out, and all we're going to have there is parentheses. Alright, and so when we do that, that'll be f and then parentheses equals to negative 2 parentheses plus 1, and then what do you think is going to go inside here? You should have said the g of x. So the g of x goes in here, and here this is going to be negative 1/2 and then x minus 1. Okay, well, let's see now. The negatives are going to cancel, right? Negatives are going to cancel, and this would be like 2 over 1, so the 2's cancel, and so what we have left here, this all goes to 1, and now what we have is x minus 1 plus 1, and the 1's, they're going to cancel, and so all we have left is x. So we can see that g of f of x are inverses of each other. Alright, and so that's what they're doing here. The 2's cancel and the negatives cancel. And so we end up with just x minus 1 plus 1, the 1's cancel, and we just get x. So now if we do the g of f of x, the same thing's going to happen. So here's f of x, negative 2x plus 1, and we're going to put, it's like we're cutting the x out of the g of x. Okay, there's f of x. Now we're going to take the g of x and we're going to put that f of x into the x in place of the x for the g of x. And so here the 1's cancel, and now we have, after that, all we have is a negative 1/2 times negative 2x. The negatives cancel, the 2's cancel, and all we have left is x, just x. So this is a check to make sure that two functions are inverses of each other, and all we have left is just the x.